All right, hello everyone. We are coming up to the end of this class. This is the second to last week. And for today, what we're going to be doing is we're going to be learning about geometry. Let me open up the the slides for today. Okay, there we go. Um, so we're going to look at geometry. At this point in my career as a high school teacher, I'm actually teaching geometry this year, so this is pretty fitting. But um, the reason we're going to take a week and focus on geometry is, as I say in this opening line right here, geometry is the most practical version of all of math. It's literally just finding out matching the numbers to shapes, which is always practical. So a just a mindset you should have in ministry is just that ministry is work. That's what ministry is. It's just doing whatever work needs to happen in order to serve people. And so never believe that you're above small menial tasks. So helping with building things, fitting chairs into a sanctuary, setting up spaces for youth or for children's activities, finding ways to make the space that you have work is something that should never be. You should never have a mindset that what you're trying to do is climb the ladder to where you don't have to do those kind of tasks. If you're taking Bible college classes and your idea is that you're going to learn how to preach or learn how to sing or learn how to, if your mindset is that you want to learn how to do something that allows you to have so much time with the microphone that you never have to help with any of the work, then I would just say that even if you get to that place, like, you're so far from having the right heart. So geometry, I definitely think, is something that it makes sense. It's something that you know it's something that I think uh, it's not at all stretch to say it's going to be useful for ministry. So to simplify what we're going to go through today, we're going to look at geometry, and basically we're going to categorize geometry. We'll simply call geometry just working with shapes. And to do that, we will work with shapes in three ways. And to classify these three ways, we will consider one of the ways we'll work with shapes will be linear, which is just the distance between 2 points. All right, you look at the linear and line is in there. So linear is just measuring things across a line. Um, so that, I mean, that can be when you're driving somewhere, you just consider it point A to point B and how far am I driving? You don't care about how tall your car is while you're driving or the width of things. You're just going from one point to another. Area, which is measuring 2 dimensions, and then volume, which is measuring 3 dimensions. And most of what we'll focus on today is area. So first off, starting with linear measurements. Um, there's mainly two ways of measuring something that's linear. Um, the English measurement is only used in the United States. I've been joking for years that one day I'll run for president, and all I'm going to do, my only platform will be that I'm going to try to get rid of daylight savings because I find it really annoying. Sorry if anybody taking this class is like a farmer that benefits from that or something, but I find daylight savings to be so annoying. And I think it's really dumb that we are on this English system rather than the metric system. So I want us in the United States to get rid of daylight savings and stop using this stupid measuring system. The rest of the world uses the metric system. Why we have our own system, it's just, I think it's dumb. So the English linear system, the idea with this is it was built to be accessed without tools. So there is kind of some practical history in it. An inch is meant to be the width of a thumb, right? So it's like, hey, this is an inch. And so it was designed so you just take your thumb and put up on something like, oh, okay, an inch. And then a foot is supposed to be, as it sounds, the length of a foot. And then the yard is supposed to be the length from your nose to the tip of your outreached arm. So you hold your arm out, and from your nose to the tip of your arm, that's supposed to be a yard. I hope as I'm describing this, something that you realize, or if you think on it for long, you go, wait, but the problem with that is that if you tell me to make something that's 5 inches, if I use a child's thumb and use 5 of those in a row, that could basically be the same size of like a really large person's thumb. So if I measure it based on thumbs and everyone's thumb is a different size, that's going to be extremely inconsistent. I mean, think about feet. I'm in Louisiana, and there's a museum that has one of Shaquille O'Neal's shoes because he played basketball at LSU, Louisiana State University. So there's actually a true story here in New Orleans. There's a museum that has one of Shaquille O'Neal's shoes, and those shoes are just insane. And so if you're going to measure something and say it's a foot long, and we use Shaq's foot compared to my foot, we're going to be way off. So that system of using an inch as a thumb and a yard is the arm and foot, it's kind of inconsistent. So they came up with a way to standardize it. And so basically the way it works with the standardized measurements in the English system, what we did is made it so that you take an inch and 12 of those makes a foot. And then 3 of those feet make a yard. So therefore 36 inches makes a yard, and 5,280 feet equals 1 mile, and 1,760 yards equals 1 mile. So we took it and we standardized the English system. And so the English system typically uses fractions. If you ever have to spend much time working on things with your hands, if you have a socket set, you'll notice that you have to, like, let's say if you need to get a wrench and you have to unscrew a particular sized bolt or screw, you'll notice that you need to look at 2 different measurements depending what kind of set you have, or some sets have both. And some of them it'll just say like 12 millimeters, 13 millimeters. It'll just have straight up numbers. And the other one will say like 7/8, or it will say 5/6 or 1/2. So one is in fractions and the other just runs in numbers. And so the English system, because all we have to work with is like an inch, a yard, a foot. I mean, think about how, like, so therefore, if you're trying to talk about how far you need to go, you could say an inch, or maybe you need to say a third of a foot or a half of a foot. So the point is that with the English system, we have to end up using a lot of fractions. And so the lessons on fractions and the lessons on conversions are both important in order to be able to use the English system. And as I mentioned earlier, the English system is what the United States uses. But if you're ever going to go to another country, you need to be ready to deal with the metric system. The metric system was created by French scientists, and what they wanted something more consistent and that used more accessible calculations. I mean, if you think about it, maybe you know this, but in general, I mean, go in America and go up to any random person and ask them, like, hey, how many cups are in a gallon? Or what's bigger, a pint or a quart? And I mean, maybe if they are like a physical science teacher, or maybe if they are like a baker that uses that stuff on a regular basis for measurements, they'll know. But most random people won't know. If you just walk up to a random person and say, hey, how many quarts are in a gallon? Most people have no idea. And that's the United States is the only place that uses that system. And none of our people know that system. Again, because there's just random relationships between the numbers. So like the English system, you're going to take an inch, and if you want to relate inches to feet, you're multiplying by 12 or dividing by 12. If you want to go feet to yards, you're multiplying or dividing by 3. Or if you're doing with miles, you have to do 5,280. Or if you're doing pints and cups and quarts and gallons, you're going to have to use 2 or 4 or 8 or 16. There's all these things you have to memorize. The metric system, the main reason I prefer it so much is because everything is a factor of 10 for the metric system. So in order to come up with distance, instead of using your nose to the tip of your arm and just hoping everyone has the same arm length, until we have to come up with some random numbers to memorize things, what the metric system originally tried to do is take what they figured the distance from the North Pole to the equator is, and they just divided this by 10 until they arrive at a meter. And the meter is slightly larger than a yard. And so then what we do with each of these things is we set them up, and I did this last week, we have a prefix you put in front of a meter. So 1,000 meters, we call that a kilometer or a kilometer. And then so that would be if I have a meter and I'm talking about going from here from Louisiana, let's say you're going from New Orleans to Chicago. I don't really want to map that trip in meters. I want something larger. So I can do it by 1,000 meters. So every 1,000 meters is a kilometer. So now I can say I need to travel whatever a couple hundred kilometers instead of having to say I need to travel millions of meters. And then if you want to go really small, so if you're measuring something really tiny, then instead of saying, oh, I'm going with 1,000th of a meter, if you're going in the small, you're going to call it a millimeter. Millimeter is 1,000th of a meter. If you want 1,000 grams, it's a kilogram. Notice the same thing. So all you have to do for metric system is not memorize how many random arbitrary inches are in a foot or cups are in a gallon. You just memorize that kilo means 1,000 of whatever I'm talking about. So if I have a kilometer, I have 1,000 meters. If I have a kilogram, I have 1,000 grams. If I have a kilobyte, I have 1,000 bytes. I mean, if I'm taking a kilo class, it means I'm taking 1,000 classes. Like kilo can apply to anything, and it just means you have 1,000 of that. And then milli can apply to anything, and milli means you have 1/1,000th. So if I have a milligram, it means I took a gram and I broke it into 1,000 pieces, and I have one of those 1,000 pieces. And so all forms of measurement use the same prefixes. You just put hecto or deci or deca or kilo or milli or centi in front of whatever it is you're measuring. And so the metric system is so much easier because everything goes by 10 and you just have one set of prefixes that you apply to every dimension you're measuring. So that's why you can tell I'm very biased. I much prefer the metric system. I wish the United States could switch to the metric system, but I understand that would confuse a lot of things. And then I guess it would ruin football. What would they call that then? The I don't know, like a fraction of a meter ball. So anyways, so here you see a kilometer is just 1,000 times whatever you're dealing with. Hectometer is 100 times whatever you're dealing with. So the metric system was covered and we did some calculations with that in the conversion class. If you remember in that class, I had a slide that had all the prefixes. So I don't necessarily expect you to memorize those. And I will just say that when you're taking the exam, there will be some calculations on that. And I think I could say that just make sure you understand like kilo, centi, and milli. And I don't think any calculations beyond kilo, centi, and milli will be on the final exam. Because the key for this class is not for you to memorize those things, because anytime you're using them, you could just look up which one is which. And I'll just say now, I will not consider it cheating if when you take the exam, you go back to the conversion lesson and you go to the page or go to the point in the lesson where I had all the prefixes. And if you take a screenshot of that and have that handy while you're taking the final exam, that's fair game to do that. I guess hopefully people are actually watching the lecture. Those of you who watch this lecture will know that I'm saying that you can do that, and it's fair for you to do that. Those of you that don't watch the lecture, skip through it, probably won't hear that this is the case, and you're at a disadvantage for not doing what you're supposed to. So there we go. But anyways, to make it clear, you can go back to the last lesson and you can pull up the prefixes of the metric system when you take the final exam if you want, and you can use that for any questions that use conversions or geometry. All right, so that's it for the linear. I'm not going to run through a bunch of calculations with linear. I just want you to understand how we deal with linear. And most of the calculations that would involve anything linear are going to just be conversions, which we did last week. So now let's talk about area. So area is keeping track of two dimensions. So like this board that I have here, this board, it's got an area, it's got a height, it's got a width. And I try to make it so it takes up most of the screen, but so area is two dimensions. So what you're going to do, we call anything that is talking about area. So if you're talking about how many feet are in a particular area, because we need the feet to go across the width, or in this case the horizontal dimension, and we need them to cover the height, which would be the vertical dimension. So we need our area to cover, or our feet to cover, two different directions. So we call it a square foot. So a foot just goes in one direction, but a square foot is a square that covers a foot in one direction and a foot in the other. So that's why when you're trying to fill up an area, you don't need to just say how many feet do I need, because feet are the only linear. So if you say, hey, how many feet of carpet do we need for this room? If you just say 10 feet of carpet, that's confusing because so it's going to go 10 feet across, but how wide is that piece of carpet? So that's why you would say I need like 10 by 10. So I need 10 feet wide, 10 feet tall, or 10 feet in two different directions. So square footage or square inches or square whatever it is we're dealing with is what we'll need whenever we're dealing with a rectangular shape or a shape with two dimensions. So for a rectangle, what we're going to do is we're going to measure the length and the width and then just multiply them. So if you want to find the square footage of a rectangular room and it's 20 feet long and 5 feet wide, you literally just do 20 by 35 and you get 700 square feet. That's literally it for a rectangle. Just multiply the two dimensions times each other and you have your square footage. So sometimes for an area, instead of actually multiplying it and saying 700 square feet, it can be common to just literally leave it as 20 by 35. So you just write 20 times 35. You don't do the calculation, and this would be referred to as I need 20 by 35. That means I need 20 feet in one direction, 35 feet in the other. But what you're going to be doing is you could either say 20 feet by 35 feet, or if you're saying it all at once, you would say square feet. So for this calculation, what we use is our formula for area. You could either call it base times height, or you could call it length times width. This right here, we have a typo here on the page. It should be saying area equals base times height, so BH, or area equals LW, which is length times width. Let me fix that. Length times width. So those are our two calculations. So I'm going to write our formulas up here as we go. I'll write them in the corner. So for a rectangle, and I'm writing it off to the side a little bit. I think it's hard for you to see this one, but I'll write them as we go, but I'll try to write them off to the side so I have room for calculations as we go. So rectangle, it's going to be area equals base times height, or area equals length times width. I suggest you write these down as you go as we go as well. Have a piece of paper out right now if you don't already have one, and write area formulas. And you'll have A equals BH, you'll have A equals LW. So if we have a problem that says a rectangular sanctuary is 62 feet wide and 75 feet long, how many square footage of carpet would be required to cover the sanctuary? And then once I do that, if the carpet is $2.50 per square foot, how much would be spent to redo the carpet? So this is going to be a very simple calculation. Let's see, the depth is way off on this video. I'm not too sure why it's doing this. I want you to actually be able to see what I'm doing here. Maybe if I move this further back. And I'm pretty sure that what I'm seeing, if I see it this blurry, it means it'll be that blurry when you're watching it. I'm gonna press pause. I'm gonna mess around and try to get this thing to start working, and then I'll press play and go ahead and do the calculation. Okay, I think I got this thing figured out. I think the way I had this position, there was a lighting issue. So all right, then we got it figured out. So let's do this calculation. So the calculation is a rectangular sanctuary is 62 by 75 feet. So we're supposed to be doing 62 by 75 feet. So 62 by 75. And so let me open up the calculator here. And so I'm literally just typing in 62 times 75. And so 62 times 75 comes out to 4,650. And so if I keep track of units, I was sloppy here. And what I should do is say 65 feet times 75 feet. And so that's how, if you're keeping track of units, feet times feet will be feet squared. So it's going to be feet to the exponent of 2 to say feet squared. Okay. And then if we look at this part B of the question, if carpet is $2.50 per square foot, and right now we're doing with 4,650 square feet, then we'll do 446.50 times $2.50. And so it's going to cost us $11,625 to get all the carpet that we need. All right, let me go back to sharing. So that is an idea of how we do these calculations. All right, let me get the slides moving again. Okay. For calculating the area of a triangle, our formula is area equals base times height, which, do you recognize base times height? Look at our previous, here, let me go. Okay, look right here. Base times height was the area of a rectangle. And notice the area of a triangle is base times height over 2, or half of the base times the height. That makes sense. Because imagine if you have a rectangle and you draw a line from corner to corner on your rectangle, you've cut your rectangle and you make a triangle out of it. That's why a triangle is half of the area of the rectangle. So for triangle, the area is base times height over 2. So then you need to paint the triangle-shaped wall a certain color. The wall is 22 feet tall and it has a length of 10 feet. What area will you need to paint? So now we have a wall that is let me look at the question again. It's 22 by 10. So area equals 22 by 10, but we're doing, it's a triangle that's 22 feet by 10 feet. And so since a rectangle, if I had a 22 by 10 rectangle, I would do 22 times 10 to get my answer. A triangle is half of a rectangle. So that's why we do 22 times 10, and then we'll just divide it by 2. I think I can do this one without a problem. So that's going to get us 220 divided by 2. That'll get us 110. So, and this problem was in feet. So our area is 110 square feet. There we go. Back to sharing. And we have the area of a triangle. Whenever we're doing with a triangle, there is something called the triangle sum theorem. And what the triangle sum theorem states, it just tells us that all the angles in a triangle add up to 180 degrees. Just kind of a math fact. And so what this does, this can kind of help you if you ever do need to care about the degrees of a triangle. And I mean, I'm not going to sit here and act like you're going to need to use this every single day, but this can be helpful stuff to know. If you're part of a small church plant where you can't just go hiring experts every second for things, the more you know, the more it's going to help. So as obscure as this seems, I actually have a true story. A couple months ago, anybody who follows my ministry and what we do on Facebook is aware of that. A couple months ago. So again, I don't know when these videos will be, how long into the future people will be seeing these videos, but in December of 2022, I'm here in Southeast Louisiana, and he planted a church. It officially launched in January of 2023, but we started meeting there in November and December of 2022, and then officially planted the church in January. Well, we had only been meeting in this church for about a month, and then in December, a tornado came through, and actually a little multi-purpose building that's used for kids' church got hit, and the roof was damaged. And I have a friend who has a background in construction, and he didn't feel comfortable with his kids going into that building. So he said, I'm going to go in and I'm going to brace the roof. And so he's pretty solid with the construction, but he's not necessarily a math whiz. So he went and bought some boards, and a couple of us guys went to the church, and we're going to help him brace some of these beams up in the roof. It's a true story. And as he was doing this, he would figure out a couple of angles, and he would so these beams, you have a horizontal beam, and then you'll have a diagonal beam. And what he knows is that he has a horizontal beam, he knows he has a vertical beam, and he's trying to figure out what angle he needs to cut the diagonal beam. And throughout the whole day, he would tell me he would measure 2 angles, And I would literally use this triangle sum theorem to tell them what the missing angle was. And again, like it might sound like I'm coming up with these obscure reasons to know this, but it was helpful in that moment. You never know when this math can be helpful. So anyways, really simple. This is a simple one, that all the angles in a triangle add up to 180. So what's happening is my buddy was calling. He's like, okay, this angle is 90 degrees. This angle is 40 degrees. What's the last angle need to be? And I would just in my head realize, okay, I need to get to 180. If we have a 90-degree angle and a 40-degree angle, we need 50 left to get to 180. So I tell him, okay, your next cut is going to be a 50-degree angle. And so we did that throughout that whole day, and we were able to brace the roof. So anyways, that's just a recent story where me knowing how many angles you need in a triangle was actually helpful. So right here, if one angle in a triangle is 34 and the other is 102, what is the measure of the third angle? So I'm just going to take a calculator, and I think the way this can work is I can set up the screen to just look at the calculator. Yeah. So for this case, I'm just going to go I'm going to clear the calculator, and we have a 180-degree triangle. Hold on a second. We have a 180-degree triangle, and we said that the angles are 34 and 102. So just subtract 34 and then subtract 102, and what's left is 44 degrees. So let's go back to the slide. So if the problem tells us that we have 34 degrees, 102, just subtract both those from 180, the third angle is 44 degrees. Simple. So the triangle sum theorem lets us find a single missing angle. The Pythagorean theorem lets us find a missing side. This is a little less simple. So what the Pythagorean theorem only works on is it only works when you have a 90-degree angle or a right triangle, which is really common. Oftentimes the Pythagorean theorem will come up, and I think there's going to be a word problem in the when I get to having you do the problems out of the book, there's going to be a word problem you're going to do, I think, towards the end of it. But what can happen is where the Pythagorean theorem, or where, again, geometry here. So that's a triangle. And if this angle is 90 degrees, which is a perfect corner, you now have a right triangle. That allows Pythagorean theorem to kick in. I'm going to get into Pythagorean theorem in a second. But this situation where you have a right triangle, you might be thinking like, well, why bother to learn this if it only works on one type of triangle? It's because it's the most common triangle that you'll actually need when you're doing a calculation. And the reason is what can happen is, let's say you have a building, and then here's your ground. So like, let's say you have a building. Here's the ground. What'll happen is the building will make a right angle with the ground. So then let's say what you want to do is for some reason, you need to tie a rope going down from the building, and the rope needs to go right here. And let's say it's 10 feet tall. Then what can happen is then you want to take a rope, and you need, for whatever reason, you need your rope to be 20 feet away from the building. So you have a right triangle, and it's 10 feet, 20 feet. And what Pythagorean theorem will let you do is find that missing length, which will be the length of rope you actually need to buy in order for that to work. And again, this is actually something that can come up every once in a while. I mean, a really common version of this is that a church planter could deal with is, let's say you have some stairs. And what you realize here, so this is a right angle. The stairs are 10 feet tall, and maybe they cover a distance of 12 feet. And so what you need to do is you need to buy a board that will go over the top of these stairs. And so I guess in this case, you would need to go a little bit above. Let's say you measure that the distance the board needs to go is 10 feet, and then the width it needs to cover is 12. And so if it's 10 by 12 is the distance we want to cover. So how long does the piece of board need to be that we're going to go buy in order to make a handicap ramp? Like that's not an out of the ordinary situation. So that's where Pythagorean theorem can come into play. And what Pythagorean theorem is, let me jump over to the slide. It's going to be a squared plus b squared equals c squared. I'm pretty sure that's all that the next slide is going to show us. Pythagorean theorem, let me go into slideshow mode here, is it works on a right triangle. and the side across from the right angle is called the hypotenuse, and it's always going to be the longest side. And then the sides on each end of the right angle are both called legs, and they will always be shorter than the hypotenuse. And the Pythagorean theorem is just a squared plus b squared equals c squared, where a and b can be either leg. It doesn't matter which one goes where, but c is always the hypotenuse. So let's do this problem. If we have a right triangle and the legs are 3 and 4, then how long is the hypotenuse? And that's probably the most common situation you're going to have, where you know the legs of a right triangle, you need the hypotenuse. So again, just to clarify what that slide was saying, you have a right triangle. The long side across from your right angle will always be the hypotenuse. And then the two sides on either end, either side of the right angle, are both called legs. And so in this case, what we're doing is we have a right triangle where one side is 3 and one side is 4, and we want the missing side. And so again, a squared plus b squared equals c squared. A squared plus b squared equals c squared. So I guess maybe what's less confusing is, instead of writing c squared, I can do it like this. I'll do it like this. So we have 3 and 4, so we'll call it a will be 3, b will be 4. How did I know to make them a or b? It doesn't matter which one's a, which one's b. All that matters is that the hypotenuse is c. As long as the hypotenuse is c, it doesn't matter which one you call a or b. So then what we're saying is a squared plus b squared equals c squared. And in this case, a is 3. So what we'll have is we'll have 3 squared plus, and then b is 4. So we'll have 4 squared equals c squared. And then if most calculators can do this, but squaring is simple. It's just 3 times 3. So 3 times 3 is 9 plus 4 squared. So 4 times 4 is 16 equals c squared. And then we do 9 plus 16 and we get 25 equals c squared. And then whenever we're doing this kind of calculation, if you had plus 2, you will do minus 2 on both sides to get rid of it. If you had times 2, you could divide both sides by 2 to get rid of it. In this case, what we have is we have c squared. So to make the squared go away, you do the square root. But again, whatever you do on one side of the equation, you have to do on the other. So by doing that, our answer is just c, but we have to get the square root of 25. So the square root of 25, you're asking yourself, what number times itself gets you to 25? And that would be 5, because 5 times 5 equals 25. You can just take a calculator and just type the square root of 25 in the calculator. But in this case, our missing side is 5. So that's how we solve that. Again, it's fair game for you to take that square root, plug in the calculator. Some problems, it's actually the only way to do it. This happened to be one where we have 3, 4, and 5 as our sides. But in Pythagorean theorem, quite often, your two legs are sides that when you square them and add them together, when you get to this step of the equation, it's common that the number you have here, when you do the square root, gets you a weird type of decimal. So it's cool if you do that with a calculator. So calculator is totally fine for that type of problem, but that's Pythagorean theorem. So again, we're still on triangles. Remember, we started with the area of a triangle calculation, and then we did triangle sum theorem, which is all the angles, Pythagorean theorem, which allows us to find the sides. And so, okay, here we go. One more example with this, and then I think we're done with triangles and we'll jump to trapezoid. So if a piece of wood is 25 inches long and you're going to use it to allow a wheelchair to climb a 10-inch high step, how far away from the base of the step will the ramp be on the ground? Okay, so let's do this problem. So it's a 25-inch piece of wood, and we're going to use it to climb a 10-inch high step. How far will it extend? So in this case, what's going to happen? Let me draw the picture. So we have a 10-inch step. So the step is 10 inches tall. And then we take a board that's 25 inches long. And the question is, how far out will it extend? That's our right angle right there. Remember, your corner is always your right angle. And if I'm going to call this A, this is across in the right angle. So we'll be calling this C. And so we don't know what B is. So when we do a squared plus b squared equals c squared, A goes in there as 10. We don't know B squared. And then C, oops. C is 25 in this case. And so what we'll do is we square, we do 10 squared and we get 100. And then when we do 25 squared, we get 225. And so then now what we need to do is we need to solve for B. So the 100 is there, it needs to go away. So if you do minus 100 on the left, it's gone. But then you have to do minus 100 on the right. So we have B squared equals 225 minus 100 gets us 125. So now we need to get B by itself. So just like on the last one, square root so that your answer is just B. But if you square root the left, you need to square root the right. And so what's going to happen here, we need the square root of 125. And so square root of 125, see right here what this calculator does, and this is a simple little calculator you have on the computer, but whatever number you have, you can type this square root button right here and it'll square root it. So let me do 125. What was the number, right? Yeah, square root 125. And I press this square root button, so you can see right here it's doing square root 125, and it comes out to 11.18. So B equals 11.18. So what this is showing us is that if I have a 10-inch tall step and I use a 25-inch long plank, then it will extend 11.18 inches away from the step. So that can honestly matter, because if the next step starts by then, well, then we have an issue here. So that's where something like that could work. Okay, so that's it for triangles. And then the next thing we will calculate is a trapezoid. A trapezoid is going to be a four-sided shape where one set of the sides are parallel and the other two are not. So to draw you a picture of a trapezoid, think about what it's saying. It's a four-sided shape where one set of the sides are parallel and the other two are not. So it's different than a rectangle, because in a rectangle, all the sides are parallel to each other. In a trapezoid, they're not parallel. So what that means is that one set is one of the sides that are parallel, one is going to be short, one is going to be long. They're different lengths to keep from having the vertical sides parallel to each other. So whenever we're figuring out trapezoids, we're going to need a different equation. And to calculate the area of a trapezoid, what we do is we take the two bases and we add them together. We then multiply by the height and we then divide by 2. So trapezoid is going to be area equals base plus base. And what we'll do is we'll write base 1 plus base 2 times height, all divided by 2. So I wrote my equation down over here. And in this equation, each base represents, or each B represents a base or a parallel side, and H is the height of the trapezoid. So how much area is a wall if the top of it is 20 feet long, the bottom is parallel and 30 feet long, and the distance from top to bottom is 10 feet? So for this one, what it's going to look like is it's a case where the top is 20, the bottom is 30. So the top and bottom are different sizes, and the distance from the bottom to the top is a distance of 10. So again, looking at the equation here, so make sure you're set up where you can see the equation. Tilt this over a little bit. Okay, so look at the equation for a trapezoid. So it's base plus base, then divide by the height, and then divide by 2. So right here, my area is going to be base, which is 20, plus base, which is 30. Then multiply by the height, which is 10, and divide by 2. So 20 plus 30 is going to be 50 times 10 divided by 2. Area equals 500 divided by 2. Area equals 250. So the area is going to be, in this case, it was feet. So it's going to be 250 feet squared. Area is always feet squared. So that's how we find the area of a trapezoid. And notice as I'm doing this, I'm storing my equations on this side of the board. That'll make the problems at the end a lot simpler. To calculate area of a circle, we need to use pi. Pi is just a number. That's literally all it is. It's just a number. And pi is, we round it to 3.14. And the area of a circle is calculated by using area equals pi times r squared. Again, A is the area and R is what's called the radius. And the radius is the distance from the center of the circle to the outside of the circle. So if I show you a circle, so if we have a circle, the area is the total area the circle covers. And then if you go from the center of the circle to the outside, that would be a radius. So whatever that distance is, that's R. And to find the area, you do pi times R, and then R gets squared. And then if you take a line and it passes through the center, but it goes from one end to the other, that will be called a diameter. So R for radius, that's going to be half a diameter because it goes from center to the end. And to go from end to end and pass through center is two radiuses, or plural is radii. It's the proper way to put it. Two radii put together makes a diameter. And so we need the radius in order to calculate the area of a circle. So let's do this example. And before I forget, let's do area of a circle. And I'm gonna write it here. A equals pi r squared. Okay, so area of a circle, A equals pi r squared. All right, so a circular sanctuary has a distance of 42 feet from the center to the wall. So center to the wall is 42. So as I'm reading this, I'm gonna draw it here, and then I'll stop sharing screen so you'll see what I'm doing better. But I'll draw things. So I'm gonna draw from the center of the circle out to the wall is a distance of 42 feet. So how many square feet of carpet would be required to cover the sanctuary? And then back to the original situation where carpet costs $2.50 a square foot. So if this is our circle and it's 42 from the center to the outside, that's our radius. And our circle equation is area equals pi r squared. So what we'll have here is area equals pi, which again is 3.14. A lot of calculators have a pi that you can plug in, and it's the whole entire thing. It's because pi is 3.14. That's when you round it. Pi is this never-ending number. So it's better if your calculator can put pi in. If not, you can just say 3.14 anytime you're dealing with pi. So area equals pi r squared, right? Pi r squared. My radius, or r, is 42. So area equals pi 42, and then 42 gets squared. So we're just going to type that all in. So if I make the screen go to my calculator, so let's look at this little calculator thing I'm using. And I'm looking through it. I actually don't know if, yeah, see, this one has pi. So see when I press the button for pi, 3.1415926. So anyways, so pi is, we call it 3.14 when we're trying to just round it. But if you have a calculator that has pi already, just use that. So it's pi. So let me clear everything. So I'm going to do pi and then parenthesis r, which was 42. And then that gets squared. So it's the square root of 42. Okay, so what I should do on this one, it all depends on the calculator you have. So the square root of 42 is 1,664. And then, pretty sure for this one, then I can press pi. Okay, so actually for this one, what I think would make most sense to do, maybe I'm gonna do parenthesis pi and then parenthesis. So do you see what's working for this little calculator? How I had to put pi in its own parenthesis, otherwise it thought I was done with the problem. So parenthesis pi and parenthesis, and then I'm doing times, and then I'm gonna do the diameter, which is 42 and parenthesis. Can you see this right here? Parenthesis pi, and it put in all those decimals for me, and parenthesis times parenthesis 42 and parenthesis, and then it should work where if I square it. So see, it's just squaring the 42, and then I'll let it calculate it all. So it's going to give me 5,541.77. So again, this one, if you remember the section on just calculators and how to type stuff into calculators, I honestly think that this little calculator that the computer has is actually harder to use than if you just have a handheld calculator. So, but that's what we end up getting. So I punched in pi and I did times and I did not the square root, but 42 squared. And we get that. And then the next question asks, what about if it's $2.50? So let's just take what we have here and multiply our answer by, by $2.50. And we get $13,854.42. So that's what we get. So you just take it, you plug in the formulas. That's all you got to do. And so we end up with our two answers for this. Okay, let's go back to the slides. I think we're going to have a couple vocab words for the circle. Yeah, so with circles, a couple of things that could come up. A chord is any line that goes from one circle to one end of the circle to another, whether it passes through the center or not. Just going from one point on the outside of the circle to any other point on the outside is a chord. So just anything that goes from, let me get it where you can see what I'm doing. So just any of these things, these are all chords, okay? But if I say this is the center, none of those things are diameters, because the diameter is a chord that goes through the center. So that could be a diameter. That's a diameter. That's a diameter. Any chord that passes through the center is a diameter. So everything on here I drew is a chord, and only a few of them are diameters. And then lastly, what we already said, to just go from the center to the side, that's a radius. Okay, so again, our three words: a chord is anything that goes from side to side. A chord that passes through the center is called a diameter. And then, as we already discussed, half the diameter is the radius. So that's all of our equations for doing area. And then when we're talking about 3 dimensions, that's volume. And volume calculates the space in a 3-dimensional shape. And normally you interact with 3-dimensional shapes every day. Calculating a volume is a lot less common. Every 3D shape has its own formula for calculating the volume, but we're just not going to get into those calculations in here. So just understand that the third layer of geometry would be finding volumes. So that's something that has, if we're taking something, that's like if I'm taking the volume of this book, area would tell me how much this, let's go like this, how much this cover takes would be area. But if I also then care about its width, I have a third dimension. So I now need volume, right? This cup would be a volume. I'm caring about the circle, the area of the circle, plus the height of how much distance this circle travels. So the calculations for volume are a bit more complex. They're a lot less common for you to need to do. So we're not going to get into them in this class. So let's practice the problems that the book has. So you're going to take the book, go to page 99. This will be one of those moments where I want you to pause. I want you to try these questions yourself. 2 through 7. I want you to try 2 through 7. And then I want you to pause the video, attempt all the questions. Once you've done 2 through 7, then press play and watch me go through them. So if you are watching right now, I'm assuming you've tried all the questions yourself. Page 99, 2 through 7. All right. So, number 1, key terms presented in class. That's okay. We're skipping that. Number 2, you're buying carpet for a classroom at the church and it's rectangle and the dimensions are 12 by 18. How many square feet of carpet do you need? So we'll start with number 2. You're literally just doing 12 times 18. Look at the equation for the rectangle right here, just base times height. So get my calculator right here, 12 times 18, and we get 216. And this is 216 square feet. So I'll just say feet squared. Okay, number 3. In a triangle, angle C is 90 degrees and angle A is 45 degrees. What's the measure of the third angle? So remember, it all has to add up to 180. So we take 180 minus 90, which gets me 90. Okay, let's do 90 minus 45, which gets me 45. So the third angle has to be 45 degrees so that they add up to 180. Number 4, for an outreach, you're lining a soccer field. The center circle is 30 feet across. What is the radius? So if I have a field and this distance is 30, well then if it's 30 across the field, then the diameter is 30. So the radius is half of that, so it's 15. So for this one, the answer will be 15. So it's just whatever half of 30 ends up being. Okay, number 4, you're painting the youth hall. The room is an odd shape. You have 6 walls. The front wall is 45 feet long. So number 5. So let's make a front wall that's 45 feet long. I'll draw that right here. And then one side of the wall is 30 feet and the other is 35 feet. One side wall is 30 and the other is 35. I think I'm doing this right. The long back wall is 35 feet long and the short wall is 10 feet. Hold on, let me see. So one side wall is 30 feet and the other is 35. The long back wall is 35 feet long and the short wall is 10 feet. And the other wall is also 5 feet. I think the fact it says the ceiling is 15 feet high is kind of baiting us. The ceiling being 15 feet high shouldn't matter. Okay, so I think what it's trying to say, it says the long back wall is 35 feet and the short wall is 10 feet. So I think what it's trying to say, and the other wall is also 5 feet. I think it's trying to say that this is 35 and that this is 10 and that the distance from one to the other is a distance of 5. I think that's what they're trying to lay out. Let me double check his drawing if that's what he had in mind. Yeah, okay. I feel like it's described a little bit weird where there's a couple other things that you could have ended up drawing and setting up, but that's the idea here. So it's 45 and then 35, and then it goes 35, goes up 5, goes over 10, and then it goes up 30. So let's find the area of this whole thing first. So what I'm going to do, I want you to picture this as if, so let me draw it like this. So this is a So basically what I'm doing here is I'm gonna ignore this. I don't care about that. I'm gonna ignore this. I don't care about that. So the big rectangle is 45 by 35. And then this small rectangle right here is 5 by 10. So this little rectangle is 5 by 10. So how do we find the whole area? Well, this thing, let's find the area of the big rectangle, which is 45 by 35, which equals, bunch in the calculator, 45 times 35, which equals 1,575 feet. But we also then need to factor in the small rectangle. The small rectangle, I'll do it in a different color even. The small rectangle is 5 by 10, which equals 50 feet. And this little area is removed from the building because of its shape. So we just need to do 1,575 minus 50, and we get 1,525. And that'll be feet squared. So if the question was just asking for the square footage of the whole building, then we would say the square footage is 1,525. And okay. Hold on a second. Oh, I'm totally approaching this the wrong way. Okay. Yeah, okay. I'm sorry. I'm completely okay. Everything you just saw, I guess it's helpful to a degree of why if you watched everything I just did. I'm doing this as if we want the area of this whole thing. So everything I did would have been helpful if that's what we're actually doing. I probably should have checked his answer key before I did this. That's my bad for wasting your time here. But I misunderstood what the question was saying. What I thought they were doing is telling us that we needed to find the area, the amount of paint to paint the floor. And they told us the height of the ceiling just to bait us. But no, the question is actually easier than what I was just setting up. Here's what the question is doing. You have 45, you have 35, you have this wall that's 30, you have this wall that's 10, this wall that's 5, and then this wall that's 35. And then each wall is 15 feet high. So each wall goes up 15. So I want you to imagine right here, you're going to have, if you're painting all the walls, right here, you have a wall that's 35 feet long and then 15 feet tall. And then right here, you have another wall, 35 and then 15. And then right here, 45 and 15. So all of my walls are going to do, basically, here's my walls. We have 45 by 15. So I just checked off that one. We have 35 by 15 will be that one. 35 by 15 will be this one. 5 by 15 will be that. 10 by 15. And then 30 by 15. So those are all of the walls because I'm taking each wall and doing the base and then thinking about the height. So we calculate all of those. And we're going to do all of those. And 40 by 15 is going to get us 675. And then 35 by 15 gets us 525. And then the other 35 by 15 is no different. And that's 525. And then we're going to do, let's do 5 by 15. And when we do 5 by 15, we get 75. When we do 10 by 15, we get 150. And when we do 30 by 15, we get 450. So those are the areas that all of these walls take up. And so what we do is we add all of them together, add all these up, and we get 2,400 square feet. And then what the problem says that a gallon of paint covers 300. So if you take 2,400 and you divide it by 300, because you have 2,400 square feet and every gallon covers 300 square feet, we need 8 gallons of paint. That's what ends up happening. That was a really weird problem. I'm sorry for wasting your time at the beginning. I misread it. I assumed it wanted the area of this thing where we would remove this corner of it. That's not all it's doing. It's taking each wall, and you picture each wall as a base with a height of 15 for all of them. So this is actually the way we wanted to approach the problem, is doing what I did here. Okay. And then number 6, so this is just a good thing to get you to think about the area. What's the area for a triangle? We calculated, we have that here. Area equals base times height divided by 2. What's the area for a trapezoid? Base 1 plus base 2 times height divided by 2. What's the area for a circle? That would be area equals pi r squared. A half circle would just be pi r squared over 2, divided by 2 to get a half. And then rectangle is area equals base times height. So number 6 is just reviewing those. I hope you did what I said at the beginning and wrote them down. All right, let me get rid of this and we can have enough room to do the last question on here. All right, so now let's look at the very last question. And there we go. All right, last question. Let's see, number 7, your church has decided to stand up a 40-foot tall cross. So we got a cross and it's a distance of 40 feet. And there will be 4 anchors securing the cross located 20 feet from the base of the cross. So here's the base of the cross right here. And we're going to go out here and secure it. And that distance is 20 feet from the base of the cross. And then wires from the anchors to the cross will be attached to the cross 25 feet off the ground. So the wires will go over here and attach to the cross to help keep it up. And the wires are going to be at a spot that's 25 feet off the ground. So that's our situation. We don't really care that the cross is 40 feet tall. Let me actually double check before yeah, we just need to know the length of the wires. So the fact it's 40 feet tall, yeah, okay. The fact it's 40 feet tall doesn't matter at all. That's kind of just, you'll see math problems will do that to bait you to learn to pay attention to the only things that matter. But I can honestly get rid of the fact it's 40 feet tall. I can even get rid of what else is going on, because all we care about here is the fact that we have something 20 feet from the base and it needs to go up 25 feet. We don't care what goes on after that. And so how long does this thing need to be? So I have a squared plus b squared equals c squared. And in this case, this is one leg. This is one leg. That corner is my right angle. And my question mark is the hypotenuse. So we can call this A. So we have 25 squared. We can call this B. So we have 20 squared. And they equal c squared. And that's what I'm trying to solve for. So 25 squared is going to be 225 plus 20 squared, which is 400, equals c squared. Wait, hold on a second. 25 times 25. Oh, okay, I'm messing up. It's 625. 15 squared is 225. 25 squared is 625. I think, did that come up earlier in the lesson? 25 squared? I feel like I said 25 squared equals 225 earlier in the lesson. If so, I messed that up, but 25 squared is 625. And so 625 plus 400 is going to get me 1,025. So I get 1,025 equals c squared. And so we need to do square root to get rid of that squared. Square root. And so the square root of 1025 is our answer. So if I take the screen and I share my calculator, I have 1000, so let's clear this out. 1025, and I want the square root of that, and it's 32.05. So it looks like the answer key is okay with me just saying about 32 for C. Okay, so basically we need to get about 32 feet of wire, probably play it safe by 33 feet, and then the wire would be able to stretch that length. Okay, so that's how we do that. What was I'm sorry if there was an earlier question where you're really confused about how I did that. I feel like me taking 25 and saying it's 625, I feel like that happened earlier when we were doing Pythagorean theorem. 20 by 35. No, not that. Here we go. So let's see. I did 3 by 4. Yeah, this one was 25 by 10. Okay, so this problem, the piece of wood was 25 inches long and 10 inches high. Okay, so whatever answer I got you on this would have been way off, because I'm pretty sure, if I remember correctly, when I did 25 squared, I put 225. That's right. When I did this problem, I did 25 squared, got 225. I did 10 squared. So you ended up with square root of 125 for the answer, which was way off. It should have been square root of 525, because when I did this problem, I should have done 625 minus 100. So my bad on this problem. I'm sorry if that confused things. I just did this wrong when I square rooted it. I did it quickly in my head. That was a mistake. But all right, so go look at these questions. If you feel like you can handle these questions, if you know what's going on with these, then you're in good shape. So I would say if you're studying for the final exam, you can flip to the end of this video, look at these, be like, okay, do I remember this stuff? Okay, I'm good to go. And then the calculations at the end of the page are always helpful too. But here's the review things. This is what you want to know. So let's wrap it up in prayer, and then that'll be it for today. So, Lord, I thank you for this class, and as we're coming to the end of this, Lord, I pray that you would just make good use of our time. Lord, just seal into our hearts and minds the things that you want to use this class to teach us. I pray for every single student, not just now, but any student that might watch this in the future. I pray that they learn what they need to learn, that these would just be tools to make them more effective for your use, Lord. In Jesus' name I pray. Amen. All right, well, we are coming to the end of this class. In I guess just a week, we'll be taking an exam, and that'll be it. So stay caught up on your stuff, and hopefully everyone finishes this class strong. All right, that's it for this week. I will see y'all next week.